we were discussing about product design. So, this is continuation of my previous lecture about product design. In the previous lecture, I told about conceptual design, embodiment design and detailed design. These are the stages of design, and then I also discussed something that how you can compare various design alternatives, particularly in the conceptual design stage. This lecture will be continuation of that. We will tell something more in that. So, if you want to compare various alternatives, then there is one good analytical technique, that is called analytical hierarchy process. So, you can use that AHP technique also, and that is what we are going to discuss here. So, it is a formal method for determining relationships between discrete alternatives. You may have alternatives very discrete form, that you have to do this, whether it will be IC engine or whether it should be motor or it should be say windmill. Like that you can have discrete options and you have to choose one. Each alternative is rated by one or more attributes. It has an axiomatic foundations which requires that the annihilation condition is not satisfied. Okay. So, this is what that we have to discuss about analytical hierarchy process, and I will explain this with an example. Okay. So, basically I am taking one example of analytical hierarchy process, okay, that means AHP, from one of my recently published paper. Okay, it is basically related to grain storage, that food grain storage. You have to store the food, in what way you have to store. So, it is a review paper, but there we have done. So, let us say first, for the sake of explaining you that how AHP can work and how it can help in the product design, let us say you decide some herbal method of storage. Okay. So, we know that we have studied that people use eucalyptus leaves, people use citrus tree, people use A indica, people use peppermint, okay, and people use this one. So, there are 4 different type of plant species, and you want to compare that how one alternative is better over the other. So, we are making paired comparison type of thing. Okay. We are having peppermint, we are having indica, we are having this thing. So, we make that in this method, in analytical hierarchy method. First we decide, suppose you are comparing eucalyptus and citrus. So, citrus is considered better than that eucalyptus. So, that is why scale is this side and it is its rank is 4, okay, something like 4 times, okay. And eucalyptus A indica is even better than eucalyptus. So, this is 6. Eucalyptus and peppermint is compared, so it is 2. Citrus and A indica is compared, this is 3. Citrus and peppermint is considered, then citrus is better, so it is 4. Like that, if we have done, and who decides that? Experts have to decide. There may be many other methods, but usually the experts will take decision. And in the other page, other figures, okay, this figure has come up to this one, eucalyptus versus citrus, eucalyptus versus, okay, that same figure, and A indica versus this thing. So, after that, what do we do that? After that, we have to write the same thing in a matrix form way. Okay. So, what we have to do that, suppose we have to say this is like this. Okay. So, maybe I am doing that like this. So, eucalyptus, citrus, A indica and peppermint. Okay. So, we have to do like that eucalyptus. Now, eucalyptus compared to eucalyptus, eucalyptus will be 1 only. But eucalyptus rank compared to citrus is 1/4, compared to A indica it is 1/6, compared to peppermint it is 1/2, because it is 2 peppermint. If you compare eucalyptus versus peppermint, then you saw that peppermint is 2, so reverse is 1/2. Similarly, citrus and eucalyptus, so citrus compare to that, so citrus versus eucalyptus. So where is the eucalyptus? This is eucalyptus, okay, and this is citrus. So citrus is much better, 4 times. So you just say that 4, okay, compared to eucalyptus. Then citrus, compared to citrus, citrus is only 1, but compared to A indica, citrus is 1 by 3, because A indica compared to citrus, citrus is basically 3 compared to this one. So A indica versus, so citrus versus A indica is 1 by 3, and A indica versus citrus has to be 3, okay. So that type of thing in matrix, it has to be made like that, okay. So this is the type of matrix you make, and then after that you make this type of matrix, okay, that, and then after that what you do that here, that you sum total this one. Suppose this side there is a, you know, this ranking, and you sum them together, that column sum. So you got 13, citrus got 9 by 2, A indica got 17 by 10, peppermint got 21 by 2, and then what happens that you have done the sum. So divide it by 13, okay, that column, whole thing, 1 by 13, 4 by 13, 6 by 13, 2 by 13, and here it is 1 by 18, like that, so that the column sum becomes 1. So this is a type of normalization, okay, that type of thing matrix you have made. And then you have to see next, the normalized principal eigenvector was obtained by summation of the values in the rows and taking their average. It was also known as a priority vector. That means you sum the first row and divide by 4, sum the second row, divide by 4, sum the third row, divide by 4. So you got a priority vector, okay, you got this type of thing. So priority vector says that this is the 0.54, that means third alternative is much better, that means A indica is coming much better. So that means A indica must be taken. So A indica must be taken, because this is what this one. But you have to also do like this, that you find out the, there is one lambda max, that something maximum eigenvalue, that 0.0695 into 13, and this is sum, plus 0.2764 into 9 by 2, and then 0.106 into 21, and this one, and then you get 4.11, okay. So this type of matrix, when you multiply and do that type of thing, then you can get lambda max, and then there is some formula that Ci is equal to lambda max minus n divided by n minus 1. So n is the number of comparisons, that means 4, and lambda max is equal to 4.188. So you get consistency index, and it was obtained as 0.06. Then there is a random consistency index. Actually it was propagated this method by Sati in 1980. So he has written one book on that, and from that book actually there is one table. He gave some random consistency matrix. So for n is equal to 4, random consistency is 0.9. So Cr is equal to Ci by Ri becomes 0.07, and it is less than 0.1. Hence the matrix is consistent. That means you can rely on that matrix. Why this issue of consistency comes? Because suppose you compare A with B and B with C, then comparison of A to C will also be consistent. It should not be that A is better than B, B is better than C, but A is better than C also. It should not be like that. Suppose one alternative is better than other, that means A is better than B and B is better than C, okay. So naturally A is the better. So you cannot have inconsistent type of thing, that you know that later on you will say no, C is better. So this type of, that means experts can do mistake in the comparison. That is why there is need to have consistency matrix. Anyway, as I said, the total score was more in A indica, therefore A indica was the best. So this is called analytical hierarchy process. Okay. Now coming to that, basically there is one method about Taguchi's method, which we will not discuss in detail right now. Maybe in the quality discussion we will discuss little bit more detail. Taguchi gave the concept of robust design, where he considered that usually there can be variations in the product, and therefore product should be sustainable against those variances. So design variable set is defined by the expected variation of a single performance variable from target value due to stochastic noise, and probabilistic optimization method can be used to evaluate the expected value of the objective function. Now I am discussing something about fuzzy design method. Okay. So compared to utility theory etc., fuzzy design method is considered much better. In this, design imprecision is manipulated using mathematics of fuzzy sets. We have concept of fuzzy sets, like in set theory, that if I say that the set of fruits, okay, then the set of vegetable. So set of fruits will contain something like mango, grapes, apple, and set of vegetable will also contain bitter gourd, lady's finger, and maybe that pumpkin. But the thing is that somebody may say that, okay, what about tomato? Tomato is a fruit in one sense, but it is used as a vegetable. So you can say, okay, it is in both sets, that but membership grade in fruit is 0.5 and membership grade in vegetable is 0.5. So that means each member can have some degree of association, which is called membership. So fuzzy sets basically like that, suppose there is A is some fuzzy set, and there are some L1, L2, L3, three things are there in that set. L1 has 0.7 membership grade, that means it is more likely to be member of that set. L2 is even more likely, 0.9, and L3 is in between like that. Similarly, B has a membership grade 0.8 and 0.5, and this is 0.6. Then you can do some fuzzy arithmetic also, like A cap B, that means A intersection B is what? So minimum membership grade, that L1 is 0.7 in A, 0.8 in B. So that means common thing is 0.7, and here it is 0.9 here and 0.5 in another set. So L2 got membership grade 0.5 in intersection, and similarly L3 it has got 0.8 and here it is 0.6. So in intersection it has got 0.6, and based on the fuzzy set theory there is a fuzzy logic also. Normal in Boolean logic, only a thing is true or false, but here it can be a combination, that means it is half true or it is 1/3 true, like that. So you do not have 0, 1, you have numbers between 0 and 1. So we can have similarly the fuzzy arithmetic also, like we can have this one fuzzy arithmetic. So here we can have some fuzzy set operations, and we can have, so if we go to fuzzy set fuzzy arithmetic, okay, that means one is the fuzzy operation, other is the fuzzy arithmetic, okay, fuzzy and fuzzy logic, okay, three things are there, but we will focus on application of fuzzy set operations. If a product has a membership grade mu1 in one objective and mu2 in other objective, its overall membership grade can be defined as, so overall membership can be defined as, I am writing it here, this is like this, okay. So that means it can be defined as mu0 is equal to minimum mu1 by mu2, okay. If there are three type of objectives and each one has membership grade mu1, mu2, mu3, then it can be overall membership grade can be minimum of mu1, mu2 and mu3. So here the overall performance of the model is dependent on the most poorly performing aspect, okay, because you are seeing the minimum. So this type of strategy is called non-compensating strategy, because performance of one cannot compensate the other. That means weakest ring type of thing, okay. Suppose in a chain will break, if the weakest link has failed. Okay, so this is the type of thing. But we can have another type of thing. I am showing it here. Suppose we can say overall membership grade based on compensating strategy may be defined as that if something has got grade of mu1 in one criteria and grade of mu2 in another criteria, then the combined one is that mu0 is equal to under root mu1 mu2. So this is the type of, if there are 3 alternatives, you can multiply it by 3 times and you can say mu1, mu2, mu3 and you can take cube root. Okay. So we can in fact take that we can have many this one. So a weighted combination of 2 strategies may also be taken. Thus if the membership grade of a model in n different objectives are, suppose in n different objectives it is mu1, mu2 and mu1. So we can have, it is like this here, we can have this one. Okay, so this is then, yeah, then it is like this here and we can have this one. So it is, suppose membership grade are in different objectives are membership grade are this much. Okay, then comma here, then overall membership grade may be defined as mu0 is equal to 1 minus alpha minimum of all the grades. Okay, see there are 5 different objectives. Okay, like cost is one objective, performance is one objective. Among them these are the membership grades, but the poorest one is some grade. So you take that poorest quantity minimum and multiply by 1 minus alpha, and here you can have alpha, and this can be mu1, mu2, mu1 can be multiplied n times and you can take nth root. Okay, and multiply it by alpha. So that means you are giving weightage to compensating as well as non-compensating strategy. If alpha is equal to 0, then it becomes pure non-compensating strategy, and if alpha is equal to 1, then it becomes pure compensating strategy. Okay, so that is what that this becomes like this, and then go to this one. So and overall membership grade based on a compensating strategy, that I have said already. So one can easily incorporate linguistic information in the decision process. For example, if a component has a membership grade mu in a set of good surface finish, it can be assigned a membership grade of under root mu in the set of more or less good surface finish. Thus the customer's requirement available in the language form may be converted into mathematical form. So you can have like this, that if you have customer has membership grade mu, so that what suppose membership grade is mu, that mu is in set of good surface finish, but in more or less good surface finish it can be under root mu, and so customers requirement may be okay, so they can be converted. And suppose it is the set of very good, then we can say mu square. Okay, that means we can be more stringent. So like that we can modify also, and we can have this one. So now what we can do, if in the area of multi-objective machining optimization or anything, the fuzzy set based decision strategy may be very effective. There are a number of objectives to be satisfied in a multi-objective machining optimization, such as we can have minimum cost of product, maximum production rate, maximum profit rate, and minimum surface roughness. In the fuzzy set based approach, different solutions may be assigned membership grades in different objectives, and then based on the fuzzy set operations, the solution having the overall membership grade may be chosen. Okay, that means in this criteria wise it is this criteria wise this. So what is the overall? So this is also has been written by many researchers, that method of imprecision, which uses the fuzzy set like this, that constraints can be imprecise rather than crisp, and it permits the customers to specify preference over a range of values. Okay, so it involves 2 strategies, as I said, compensating strategies in which aspects performing poorly are compensated by aspects performing well, and non-compensating strategy in which poor performance in one aspect cannot be compensated by good performance in other. Okay. So, compensating will be product of the membership grade and taking some root of that, and non-compensating will be minimum. So, this is the type of this strategy we can have, and we can actually take decision based on that. Okay. I am not giving much example on this, but you can use that method, but let us see that we are giving that example about rolling mill design and how you do that, take some decision based on some decision table. Okay. It is like that we often call it some type of priority decision table. Okay. So, I am giving one example of that conceptual design. Suppose we have to design a rolling mill, and there are three alternatives for roll gap adjustment. One is uses bevel gear, other is spur gear, and the third one uses universal joint drive. Okay. So, bevel gear drive means it is something like this type of design. Somebody has made some rough sketch about the problem. Spur gear drive will be this type of thing. There will be gears, rough sketch is given. We will not go into much detail about that, because we are just telling how to compare this one alternatives, not that I am teaching the technical teach of this one. But the universal joint drive is that suppose you have universal joint, and by that you can keep up and down, and then you can have a type of table. Okay. So, we can have alternatives, we can put it here. Criteria: design simplicity, economy, ease of assembly, ease of maintenance, efficiency of power transmission, and then reliability. And then you also have to think that how much importance you give in a scale of 1 to 10. Design simplicity is 10, economy is 9, ease of assembly is 8, ease of maintenance is 8, efficiency of power transmission is 9, reliability is 9. And bevel gear drive has got in that criteria wise rating. Bevel gear drive is design simplicity, not very simple design. So, you give it 7, economy wise it is okay 8, ease of assembly is not so easy 6, like that experts have given. So, this is rating RA into I you calculate, that is weighted rating. Then spur gear drive, that here also you see that ratings have been given in different criteria, and then multiply by the corresponding weightage alternative. So, RA into I, economy this is into I. Universal drive, that ratings have been given, and then importance is given. So, 10 into this 100, and this becomes this one. So, rating into I, that means RA into I product you see, and then after that sum them up. So, you got 390, and here RA into I, that means 407, and here you got RA into I 462. So, therefore, out of these three designs, 462 is coming much better. So, therefore, I decided to take universal drive, this one. Somebody might say that okay, I was thinking it is very obvious that why you unnecessarily you are doing this thing, and maybe many questions that how you decided that economy should have importance 9, how you decided that rating is 9 in this universal joint has in economy 9 rating, but bevel gear has 8. Well, I have taken based on some decision, that means bevel gear manufacturing will be expensive. So, that is why I have not put in economy, universal joint can be taken. But even then I may make a mistake, that expert can make a mistake. So, what is there, but advantage is that if there is a mistake, then later on if you have documented, then later on you can modify that. Okay. So, it tells a systematic way, something is better than nothing, that is why we are doing. Otherwise, designers' creativity and intuition is of course superior, and you cannot say that you can do that, but all the time expert designers may not be available. So, if you document the things, the basis will be known. So, maybe I can explain that one more example in that thing, that about robot design, that suppose there are 4 alternatives for conversion of rotary motion to reciprocating motion. So, one is the rack and pinion, you can use rack and pinion method by which rotary motion can be converted to reciprocating one. Then slider crank mechanism can be there, screw and nut can be there, and cam and follower can be there. Now, what we do that here, I have made a rough robot diagram, okay, line diagram. I am just trying to reciprocate it, and I have to think that what type of mechanism I can put. This decision has to be taken. So, I again make the alternatives that what are my issues, based on which things factors I should take decision. Let me tell that selection of the factors itself is subjective, no doubt about that, but let us say documentation is always better. So, we consider that simplicity, precision, resolution, efficiency, ease of manufacturing and ease of assembly, smoothness of operation, and all those type of factors I have taken, and then I am giving the importance to each factor in my opinion. Like in my opinion, suppose I made this as a BTech project. So, that is why ease of manufacturing was very important, ease of assembly was important. Other factors, economy, smoothness of operation, I did not put, I think, anything of economy here, but economy can be put here. That means if your money constraint is there, those type of things can be also put, but design simplicity I put, that is not so important. Design can be complex also. So, 5. Precision was not so important for me because I just wanted as a demo robot. So, 4 like that. Then rack and pinion gets what rating in this criteria? Simplicity wise, rack and pinion gets 8. Slider crank is not that simple as rack and pinion. So, 5. Screw and nut is very good. Screw and nut easily you can make 10. Cam and follower 4. So, like that precision wise, that this is 8 and this is 5, this is 7, this is 5, and then I have put all the type of rating, like smoothness of operation, rack and pinion got 10, but slider crank motion will not be that smooth. So, I have given it 6, and the screw and nut will be basically 8. So, I have given here that basically 8, and cam and follower will be 4 because it will not be that smooth. So, thinking that it will not be that smooth, I have given 4. So, in each one I am doing the product of RA into I for each alternative, rack and pinion RA into I 40, 32, and then I am adding all these points. Okay. So, I got total 0.404 here, in slider crank I got 385 here, and in screw nut I got 0.346 here, and then cam and follower we got 282. So, this is basically, sometimes some people call it a priority decision table also. Okay. So, sometimes they may call it priority decision table. Okay. Priority decision table or matrix, whatever is that thing. So, that terminology, somebody may call it by some other name also, that basically it is somewhat similar to Cook's method only, but Cook's method that you give only plus minus 0, but here you are giving that other numbers also in 1 to 10, and you are doing that. So, this is what that you have. So, based on that, if we see that the best score came of rack and pinion. So, rack and pinion has become winner in this case, that means I will choose this one. But later on, suppose my superior boss reviews that, and he may say no, you have given unnecessary very high this one, it is not that, in my opinion this is like that, then it can be changed also, but documentation is always better. So, it is not that precise type of science like physics laws etc., but these are subjective decisions. Even then we are trying to make the mathematical basis. So, conclusions, that means there are a number of ways to approach the design problem of a particular product, number of ways you can design. Now, formal design method provided a crisp method to choose among many possible design, that why systematic method, how you should, so many alternatives are there. So, in the form of numbers etc., you take a proper decision. A formal method of design is employed right from early stages of design, then better product design will better emerge. That is why we are trying to use the formal design method. This is what that my conclusion of today's talk. So, this we have told about the product, maybe some exercise problem, some hypothetical problem on the choosing of a proper concept etc. can be done by the students, then it can be useful and we will do that. So, we are now trying to conclude this topic on the product design, and then next we will be starting another topic, okay, particularly what are the types of production, this one. So, till then, goodbye.